Okay, so today we're going to talk about solving rational equations. There's two methods to do this. The first one is using proportions. Now, a proportion is whenever you have a fraction equal to a fraction. Okay, this is the only time whenever you can cross multiply. So for example, I have 7 over x minus 6 is equal to 4 over x. So I have the fraction equal to the fraction. So once we have that, you can cross multiply. So you will have 7 times x, which is 7x, is equal to 4 times x minus 6. You can distribute the 4, so you get 7x is equal to 4x minus 24, and then just start solving for x. So I need to get all of my x's on one side. So minus 4x on both sides. 7 minus 4 is 3, so I will get 3x is equal to negative 24. Then divide by 3. So negative 24 divided by 3 is negative 8. So you always want to check for extraneous solutions. Extraneous solutions are just extra solutions. Okay, so double check your work. Plug your solution back into the original equation and make sure that it works. So for example, we can plug in negative 8. So we'll have negative 8 minus 6 is equal to 4 over negative 8. So negative 8 minus 6 is negative 14, so we have 7 over negative 14 and 4 over negative 8. Well, 7 over 14, that reduces to negative 1/2, and 4 over negative 8 also reduces to negative 1/2, so it checks out, it works. Another way to think about it is talking about restricted values. So if you take your denominators here, x minus 6 and x, and set them equal to 0. So in this case, our restricted values, x can't equal 6 and it can't equal 0. Every other number will work except for 6 and 0. And since x equals negative 8, it's not part of those numbers, then that solution should work. Let's look at number 2. So again, we have the fraction equal to the fraction, so we can cross multiply. So I will get 3 times 2a plus 1 is equal to 7 times a minus 8. You can distribute, so you get 6a plus 3 is equal to 7a minus 56. Start to solve for a. So I'm going to subtract 6a. I'm going to get all of my a's on one side. And I'm going to add 56 to the other side. So that cancels and that cancels. So 3 plus 56 is 59. 7a minus 6a is just a. So to double check your work, you plug it back in. So 3 over 59 minus 8, does that equal 7 over 2 times 59 plus 1? So 59 minus 8 is 51, so we get 3 over 51. 2 times 59 plus 1, that ends up being 119. And if you reduce those fractions, 3 over 51 can be reduced by 3, so you get 1 over 17. And 7 over 119 can be reduced by 7. You still get 1 over 17, so it works. Another way to think about it, look at your restricted values. So if I set a minus 8 equal to 0 and 2a plus 1 equal to 0, then that means that a cannot equal 8 and a cannot equal negative 1/2. Those values are restricted. They make the denominator 0. So since 59 is not part of those restricted values, this will work. So what do we do whenever we don't have proportions, whenever we don't have a fraction equal to a fraction? This is when you have to get common denominators. So looking at number 1, we have 4/3 minus 7 over n is equal to 1 over 6. Now you just need to get common denominators on one side of the equal sign. So what I'm going to do here is I'm going to basically make this side one big fraction so I can do proportions and I can cross multiply. So to get your common denominators, we have 3 and n. So we got to multiply by the other denominator. So this one's going to be multiplied by 3. So n times 4 is 4n, minus 7 times 3 is 21, all over 3 times n, and this equals 1/6. Now we have that fraction equal to the fraction, we can cross multiply. So we will have 6 times 4n minus 21 is equal to, well, 3n times 1 is just 3n. You can distribute your 6, so you get 24n minus 6 times 21, I believe, is 126, is equal to 3n. So we can subtract the 24n from both sides. I get negative 126, 3 minus 24 is negative 21n. Divide by negative 21, and you get 6. N is equal to 6. Check your answer. Is 6 an extraneous solution? Is it a restricted value? So if you look at your denominators, we have 3 here, an n here, and then a 6. So the only denominator with an n in it is that second one. So we set that equal to 0. All this is saying is n cannot equal 0. Since 6 is not 0, n does equal 6. That is your solution. So let's look at number 2. I have p over p minus 2 plus 2 is equal to 8 over p squared minus 4. So we have to get common denominators on that left-hand side first. So with this one, I'm going to put it over 1, and then I'm going to multiply by my other denominator, the p minus 2. So what I get is p plus 2 times p minus 2 all over p minus 2 is equal to 8 over, well, p squared minus 4, that's a difference of squares. I'm going to factor it, and let's see if that helps me in anything. Okay. So I'm going to distribute the 2 here. So I will get p plus 2p minus 4. I'm just going to simplify that right now. P plus 2p will give 3p minus 4 all over p minus 2 is equal to 8. And then p minus 2 times p plus 2. Okay, now I have the fraction equal to the fraction. I can cross multiply. So I will get 3p minus 4 times p minus 2 times p plus 2 is equal to 8 times p minus 2. Now if you notice, something that's the same on both sides is the p minus 2. So really, if I divide by p minus 2 on both sides, they go away. So now all I have left is 3p minus 4 times p plus 2 is equal to 8. I can distribute and FOIL. Okay, and what you get is 3p squared plus 2p minus 8 is equal to 8. I'm going to continue this on the next page. Okay, so I have this. Now the way to solve this is probably going to be to factor. So we need to get this equal to 0. So I'm going to subtract 8 from both sides. You get 3p squared plus 2p minus 16 is equal to 0. This is where you would probably need to use the Berry method. Okay, so 3 times negative 16 gives negative 48. You need two numbers that will multiply to negative 48 but add to 2. So let's try 6 and 8. It has to be a positive add to 2 but multiply to a negative, so we're going to make the 6 negative. Then I need to factor a 3 out of the first one. You eat your berry, then set each factor equal to 0, and solve. So p equals 2. 3p is going to equal negative 8. Subtract 8 from both sides, then divide by 3, so you get negative 8/3. Now, if you look back at the original problem, in our denominators, we had p minus 2, and then p squared minus 4. So if you find your restricted values, p cannot equal 2 or negative 2. So this solution right here, this is a restricted value. That means that your only solution is negative 8/3.